Thank you very much for sticking around. This is the second part of the CPD, and this was the last slide we finished basically about salt. And the question which is at the bottom on the screen is how we do address salinity, what we do about salts, and generally dampness. The materials what used is Roman materials because obviously we are not doing everything on site because it's just too inconvenient and too complicated, plus we don't have the necessarily all the materials and the detailed expertise like the Venetian masters have and had. We're using the materials of a company called MGN. They have a factory about 30 miles from Venice, 45 minutes from Venice. This is their catalog, and we're using some of these products, but we're picking up everything, and then hopefully, we know the solutions if anything needs to be done. I'm just going to give it to you just if you want to just to kind of pass it on. I have a copy here. So fundamentally, this company MGN has been founded by a very well-known master craftsman, Naldo Bussato, third generation craftsman from the Venice area. He has the picture over there. And he has been working on lime sites since the age of 9. Today is about 65. And he is one of the prominent conservation figures in Italy. And he is, as far as I know, currently the last living restoration master of Venice. There were other old people, they unfortunately are not with us anymore. And he is the last one, and he's now passing on as much as he can, his knowledge. And MGM was the first company in the 1980s, early 80s, which started supplying these really high-class conservation products in an easy-to-use form. Everything very high level, all the prime materials, what they have, they are actually certified to European standard, including the sand, washed sand, river sand, no salts, and the final materials are also certified. They have been working a lot with the Department of Cultural Heritage, the Superintendenza in Italy, kind of the Italian historic England, at very, very high level, doing research, Politecnico Milan and other things. And the knowledge is just really, really, really just on a different level. And I can see that you also know a lot of things, so very much appreciate your feedback. Regarding the salts, I think this one is, Now, in salty environments, we have this quote-unquote lime tanking material, if you want to call it, but it's basically it's a waterproofing lime. This is a commercial product, it's called Rinzaffo MGN. Rinzaffo in Italian means base coat. That's what it is. There are many, many types of base coats in Italy, like almost every company has some sort of base coat. This is the type of base coat manufactured by MGN, which does this. This is based on Roman formula, has no cement, no chemicals. It's basically just earth materials mixed together skillfully, actually, to get the job done. Has been used on several thousands of sites in Venice. It's the only lime I'm aware actually can be submerged in seawater for decades and actually survives. And it's not broken down. It's actually on the tides, easily 50 years. The reason it's 50 years because some of the early applications from the early 80s, when they have developed the formula and everything, they started applying, they're still monitoring and they haven't failed. That was 40 some years ago in Venice. It's still working. There was a test, you can see it at the bottom, and then it's here. Kind of explains the concept. This is a large metal tray, about 4 meters long, massive heavy-duty tray. It's being loaded with seawater, and 2 walls are sitting in the seawater, basically proper wall sitting there. One wall has been plastered directly on the brick, kind of let it there, soak in the seawater. Obviously, in this case, it's rising then because it's rising through the brickwork. The other one has been this brown plaster, has been applied as a base coat. This is exactly what you see here. It's brown because of the color of the volcanic pozzolans. And then another decorative lime coat has been applied on top for comparison. They have been doing all sorts of tests, in order to make sure that it bonds or not, how well it bonds and how statically how well it behaves. And this has been actually left here for 22 years. So that's how far they test their products. 2 years later in Venice, a normal lime plaster looks like this. That's kind of how long a normal lime plaster lasts. 22 years later, you can see the product is everything is completely intact.
And is this above the water line? Or do they...
This is above water line, yeah, because the water line is somewhere here. And what they have done, they told us basically that this is, it's not just about, that you take seawater and kind of test it in Venice conditions. They have actually added salt from their pockets, kind of piling it up because they were actually stressing the material, how far they can take it. So the salt content of this water, according to the owner of the company that basically was doing the whole thing, it's about 10 times compared to the seawater. And then in addition to that, once it basically has been soaked there for years and years, they have taken the whole ensemble, the whole tray, they pushed it up to the hot Italian sun out there and let it actually cook. The water completely evaporated, which never happens in real life. Everything dried to get the maximum salt expansion. And they went through the whole thing, and you can see it stays intact. And this is just a quick experiment. We have taken 2 bricks, we cut them in half or broke them in half. This is a normal lime here, and this is this Roman brown lime. And you can see with the infrared thermal camera, normal lime water goes up, which is nothing wrong with it, that's how it behaves. And the other one, it doesn't, and you can see this 4 degrees difference. So also the thermal insulation of the wall is much better. In a summary, any plasterer can use this plaster. You don't need any special skills. Even if there's someone who never worked with lime or actually is not a lime plasterer or a heritage plasterer, they have advantage obviously because they know how lime works. But anyone can apply it. I would probably say it has 2 important points which needs to be respected. The thickness is important. They say that if you apply it above ground level, have minimum 10 millimeters, kind of one coat 10 millimeters. If the wall is all over the place, you have a stone wall or church wall or something like that, give it a hand, kind of level the walls if the wall is all over the place, and then apply it on, then you apply a coat, and that's your waterproofing coat. If you are underground, cellar, tanking scenarios, you need 2 coats. That's what it is.
10 mil thick.
Yeah, so basically you are going for 20 mil. And what is interesting about the plaster and how does it work, someone asked me actually tell what the mechanism is. The plaster, normal lime plaster has a 0.1 to 1 micron porosity. And what is interesting, if the porosity is under 0.2 micron or 200 nanometers, basically kind of very, very small, 0.2 microns, you don't get liquid water action. And because normal lime has between 0.1 to 1.0, about 80% of the lime porosity actually lets liquid water through, and that's why it behaves how it behaves here, which is totally fine. That's what we expect of lime. And if you mix the pozzolans in the right proportion with the lime, the pore structure will shrink by about an order of magnitude. It's going to go down to 0.01 to 0.1 microns, and the whole porosity, maybe apart from the odd one, but the whole porosity basically is going to be under 0.2, the critical 0.2 microns, which means that you're not going to have liquid water. It's going to act as a breathable filter. And why is this important? Is because you can deal with damp walls and you can deal with salts in many ways, in several ways. One of the ways how it is, for example, the NHL plaster, like Unilit and other plasters, what they do, you apply it on the wall. The NHL obviously has a smaller pore structure, but what they do, the salts, they go into it and they have a buffering effect. They actually, you apply 20 mils or something like that, and it will hold the salts back for a while. But once the salts go into the lime, they're going to actually start breaking down, and then it fails. This plaster, because the porosity is so small, and for the salts to be making damage, you actually have to carry the salts into the pores of the lime where they crystallize and they force and they break it down. Because this lime doesn't have capillary action, it means that the salts are not going to go into the lime and they're not going to break it. So as a result, basically stays long for a very, very long time.
And is that essentially your finishing coat because it's called a
No.
base coat?
It can be applied. No, this is normal base coat. That's why the color is kind of almost trivial. For example, when you use it in a basement, you can apply it, let's say 20, 25 mil. And that's it basically, and you can leave it unfinished if you want. But it has been designed, the best results, basically, if you want to even a basement. This is a microporous lime. So imagine this is a damp wall. It means that the vapors are kind of flying through the pore structure, and you have quite a bit of vapor movement on the surface. So what they do, they take a macroporous lime like that one, for example, which my colleague has, there's pink lime on the top. And that one is a normal macroporous lime. So it means that if you imagine that the vapors are coming through the capillaries, this is kind of diffuse the whole thing. So rather than coming through one capillary, it's going to actually go through and then Technically, you can paint it, but we never recommend, the manufacturer doesn't recommend, because I don't know how long it's going to last, because you have the ongoing vapor movement, but you can paint the next coat.
Yeah. And you apply it internally?
Internally, externally, anywhere.
So if you, sorry.
Yeah.
I'm very excited.
Yeah.
So if it's on externally,
okay,
and it gets wet,
right here, yeah,
yeah, it obviously the finished coat gets wet, which then goes back onto that, but that will not take on the moisture. It's fully permeable, but it won't take on the moisture.
Yeah.
So the moisture is held within the finishing coat.
or the main coat, whatever. Yeah, yeah.
I'm just trying to.
Correct. Yeah, yes, correct. By the normal line.
Yeah. Will that then cause a potential problem of freeze-thaw action in the finishing coat? It won't touch that, but would it cause a problem?
Most likely not, because you have no salts in this. This is a completely salt-free mortar. All MGM products, they actually have been manufactured and are manufactured. You can buy a normal finishing coat from the merchant somewhere. The MGM mortars actually specifically, basically, they don't contain salts, because they know what the salts do, and because they are very, very low salinity or no salinity salts. Then it means rainwater hits it, and it evaporates out. It's not going to be held in by the main coat. And one important thing is when you apply this on the wall, you apply it in a single coat, let it dry. It dries in a day or two. Since summertime, you can pretty much go on the next day on top of it. And even if it hasn't cured completely, because it's a carbonation process, you can still apply it, and you can actually go with the next coat. What is if after you apply the lime and let's say you leave it a couple of days, we always recommend leave it a couple of days to dry. And when the material changes its color from kind of a dark brown, kind of like on the back is kind of a chocolatey color, to a kind of a lighter uniform brown, because the water evaporates out. If you see damp patches on the wall, kind of darker spots, that's an indication that you have insufficient thickness. And you see that especially in stone walls, because maybe the plaster didn't pay too much attention, and you have 15 millimeters in the depression, you get 5 or 3 millimeters kind of on the top of the stone, which is kind of sticking out. And because you have a damp wall behind it, and the vapors are coming through, because you don't have the substance, the thickness of the material to diffuse that vapor movement, then the material, the vapors which are actually penetrating the breathable material starts condensing on the surface, and they're going to give you a damp, kind of dark patch. And you think that the lime is leaking. No, it's not leaking. It's holding the liquid water, but the vapor movement condenses. What you need to do, patch it up, just throw a bit of material, to apply a bit more thickness, because if you put thickness, then the vapor can diffuse in the mass, and it's going to look dry. So the material, quite interestingly, is going to tell you when you don't have enough thickness.
If you're applying a coat on coat, you don't have to scratch the surface for bonding.
You can, yes, and this is in the video. What is important when you scratch the surface, don't kind of cut it, just quickly, but use a serrated edge, or use a wet brush, just a plain wet brush, and give it a light scratch. But this is fine, just a bit of texture rather than cutting into the materials. And all these points are basically, you have this video, everything is on the video, it explains the concept. But what is important, don't over thin it, and make sure it's basically the surface is actually is closed off. That's it. So, okay, replastering is very, very common. We have an old wall and we need to replaster it. The common solution, what we do here, is we hack the wall off, and then we apply our main lime plaster, 15-20 mil, and then we apply a finishing coat, which is optional. If someone wants to kind of leave it kind of gritty, you leave it like that. If you want a smooth finish, you apply a putty lime kind of finish, and that's what it is, and let it carbonate, and that's it. The problem with this is, again, are the salts, because if you apply this on a sheltered area or the upper part of the building, you're going to be fine for many decades. But if you apply the same solution on the lower part of the wall where you have salts, or in a cellar, then chances are that this is going to fall off the walls pretty shortly. I mean, within a few years anyway, within years, and it's not going to last you decades. So the improved solution is that you hack the wall off, and then you apply this Roman base coat first on the wall before you put anything else. And this can be applied, by the way, you can apply it on cementitious surfaces. If you obviously it's not ideal, but if you have something, you have a beam or something in a wall, you can actually use it as a bridging coat, and from that point on, you just build on the cementitious surface on lime. So it's very, very tolerant. It actually sticks to almost anything. And for example, if you have these metal beams, sometimes we had like you cannot put a plaster on a metal beam. We have a solution to that too. Everything what you know about building conservation stands.
Is there any fire rating standard for
A1. A1. Yeah. Everything stays as it is. The only difference is we apply the Roman base coat. What this does in an oil building is it's waterproof if it's needed, but more importantly, it's going to give you a breathable salt barrier. So it means that nothing will come through and your lime is not going to blow in 5 years or 10 years time. It's going to last you decades. As a general rule of thumb, not applying or applying this material, as a rule of thumb, it will make the lime plastering last about 5 to 10 times longer, probably 10 times longer. So one of the benefits of this material is because the breathability has been put together in order to be, is considered a very breathable material, but it's not in rigid numbers, is not as breathable as your most breathable lime putty mortar, which has actually the big, chunky, big holes. But what it does, actually, it does a very interesting thing. It will, through its microporous pore structure, it will let the vapor, so it's going to control the humidity internally, which is also very important. So it means that you have this old wall, let's say it's in a basement or whatever, or get a lot of rainwater. It means that the wall is saturated with water for 2 or 3 days. It doesn't let that vapor load transfer into the room and create condensation and creates all things, but it actually uniforms. It's almost like having low ventilation in a building, which actually keeps the flow regardless of what's on the other side. So it actually controls the humidity, and this way can minimize the condensation, and it doesn't make the moisture move higher. It doesn't deflect like the cement, doesn't contain. So it actually has a moisture control mechanism built in the material.
So in that sense, it's good for use on internal walls, above ground level.
You can use it anywhere. You can use it above, underground. I'm showing the other cases. These are about chimney areas. So this is kind of another thing. Sometimes you can see these things around chimneys, the crumbling and the flaking and all these things, it's discoloration. These are again caused by salts. The black soot in the chimney contains sulfates, high concentration of sulfates, and sulfate salts, they start pulling in humidity and they create the same thing because you have a salt problem. And what do? You either put plasterboard, sometimes they use NHL, sometimes they use cement, when you have a chimney breast area. Easiest way, you hack everything off, you apply the Rinzafo base coat, that purple coat first, and then you replaster with a lime, you have a long-term solution to the chimney problem. The problem what I find often in chimneys, a lot of builders, they don't know about the chemical effect of salts. They try to look for the leaks, which is a good thing. They couldn't find it, and they take the chimney down, they have no chimney. And then 2 years later, the problem comes back because the problem is inherent in the salts. And you get the discoloration and all these things. The crumbling, very, very similar, is actually, it's a chimney salt issue. And what you need to know, you need to actually take the plaster off, apply a salt resistant or a salt barrier, and apply a lime, and you don't have a problem with it. And you have no discoloration. And by the way, the same material, if you want, you can apply it for the pointing the chimney stack if you want, because it has some more flexibility than cement. It's waterproof, and it holds the stack together if needs to. Rendering outside, wind-driven rain, can be a problem. And fundamentally, again, what they use, cement, very, very common, unfortunately, until it works. Or if you apply a lime render, it's very similar, it's kind of the opposite of the plastering. Now you apply the kind of a render outside, and then the problem, again, is you get the salts and you get the humidity. And the obvious solution, you apply the same material under. And what it will do, because now it's on the outside envelope of the building, this will create a very good, breathable water barrier. So you can have actually massive wind-driven drain in coastal areas, which is also, you have the salinity problem. It's not going to actually get into the internal envelope of the building. And then you have a macroporous evaporating layer on top, which will actually dry the whole thing fairly quickly, and then it's protected.
So in terms of the two different applications, if you're comparing external to internal, is there a difference in terms of migration of salts between the two? Is one better than the other, or
No.
both stable?
Both stable. And also if you need to, let's say you have an old wall, which has salinity, whether you have a beach close or not, doesn't matter. Probably what it is, if you're looking at this old wall as it is, and if you need to re-render, you apply the base coat under the render, and if you need to replaster, you apply the base coat in order to protect the plaster from the source. You apply as a base coat on both sides, and it lets the wall breathe.
I just wondered if there was a difference
No.
between the two.
Once you get it, it's a very simple concept.
Once it gets stable, once it's
Yeah.
there, then...
Yeah, it's there, and you don't have problems with it. There are no complications, really. I show you, this is a case which basically about rendering Venice oil storage. It's a massive building, like 9 football fields. It's not only it's a Venetian building, but they have used this building to store salts. That was the salt storage of Venice. So I think chances are that this might be one of the most salty buildings in the world. So this is how it looks like, kind of outside. You can see the hygroscopic effect. You go inside, it's a museum, some part of it. You can see it's like massive church walls, and the salinity is on a completely different level. It's salty. And then if you look at it, I mean, you can take chunk of salt, like massive amount of salt. I have seen something in Portsmouth along the coast, you see in certain houses. So we saw something similar in the UK. But this is how kind of it looks like the surface. You just have the brick, and the salts are just everywhere falling off. It's a really kind of extreme case. Outside, on the render, you can see this is the old historic brickwork. This is the Rinzafo plaster, the Roman base coat, the brown one. And on top of it, we have this kind of pink brick color plaster. This is a very traditional Italian plaster called Coccio Pesto. I didn't spend too much time. Basically, this is the formula, what we have here, the base coat. And then this one, this is lime, putty lime, and brick dust. Brick basically burned at low temperature, 600 degrees, because it has different pore structure. You mix them together. This is a very typical Italian product, very loved by the Italians. And this is the material which have been on the Roman baths, pretty much as a plaster all over the place. What is exceptional is the moisture buffering capacity. You have in a basement, you have a lot of humidity. This will absorb and release it. Obviously, you need ventilation, but it actually gives you a very dry feeling of the building, the Coccio Pesto. Yeah.
I'll take you one stage further.
Please.
Take you back to Bongarouche.
Uh-huh.
The one thing that they use is a pozzolanic valley, which is what you've got there.
Mm-hmm.
That's an infused pozzolanic lime mixture. The walls of Brighton and Hove, which we go straight back to Bongarouche, are infused quite strongly with brick dust, made from bricks from the outside of the clamps, baked to 600 to 700 degrees and turned to dust very easily. And the first 2.5 to 3 metres of the Bongarouche walls in the Sussex Square region are highly infused with brick dust. So what you're saying to me about that absolutely signs off. It's a big tick in the box of what you're doing and what I understand.
It's an exceptional material. I'm going to show you a case study, a basement, what we have done.
It's a brilliant mix, that is.
It's amazing. One thing when someone tells you about it, and second, when you actually see your own eyes how it behaves, it's just really, I show you in a moment the slides. And what we can see here, this is an example. It's an unusual example, because after about 20 years or something, this material, you can see the Rinzafo is failing. And we asked specifically in Venice, like, what's going on, from the Venetian, like, what's going on, why not 50 years here, which is not a big deal, because it's Venice, and this particular building, 20 years or 15 or 20 years is a long time. And what they said is that the reason why here is this base coat is failing is because they haven't cleaned the surface well. It's one of the things, it's people are buying it, all sort of clients are buying it, and the plasterers figured it out. And that's what I have been told, is that if you don't clean the wall very well, or you do a kind of a half job or something like that, like that, then it's going to basically, then you have to replaster after about 20 years, you get additional business after it. And it's very important not only just to clean the surface, like dust it and everything, but if you can and you have the possibility, wash it off, because it will wash the salts off. But one interesting thing, what we have learned from here, and this is a large building, you can see that when this harder lime, this Rinzafo material fails, it fails off very gracefully. It doesn't damage. This is a soft, 500 plus year old very, very salty bricks. I think it's as bad as we can get in the UK. And it's in pristine condition. It doesn't damage the bricks.
Yeah, because cement renders it
Yeah.
terrible for that.
Yeah. And I'm doing some research on this. My gut, based on all the data which I'm looking at, and this is what it is. When you apply a cement on the wall, again, I'm doing the research on this. So this is just sharing my own thoughts so far. It's not the hardness of the cement which is the main issue, the hardness factor, because the Romans have created harder limes and it didn't damage and they lasted. The problem, I think, is that why cement damages the buildings and creates all this decay and this horrific decay on the bricks and the crumbling and everything is probably because of the salts. And unfortunately, in the UK, seems to be not too much. It's not a general, is no general awareness of the salts. It's a new story. Everyone is talking about dampness, but in fact, the salts are more important than dampness. And as a result, chances are this needs further research, but the data is pointing in the direction that probably what causes the damages with cement is more the salts than the hardness. And when we compare lime and cement as two different kind of the opposite end of the spectrum, and we come to the conclusion, lime is good, cement is bad, it's not only about, and we say, okay, it's breathability and it's the hardness. No, because the salts are very often not mentioned, and it's a major difference because the limes are non-salty and the cements are very salty. And it's one of these kind of flying under the radar variables which nobody talks about. And it might be the case that we're blaming in many instances the cement because of its hardness, when in fact hardness is important, or softness, but it might not be the main cause behind the decay. Just need some research. And then we have another one, the basements and the cellars. So basement and cellar can be quite challenging, and we see all these solutions. They tank it and they apply cement tanking, and then it drives the moisture way up. It starts blowing after a few years above the tanking. So yeah, I think we have all seen that. So on the left-hand side, we can see kind of in a cellar what are the issues. You get water ingress here, you can have rising damp, you can have salts, you can have penetrating damp, which usually dominates, you get condensation. If you put a tanking, you can actually drive the moisture up and the salt up in the building and pushes the rising damp up. So there's a number of things. Every cellar is slightly different. And when you need to deal with why people don't use lime in a cellar, because we know that lime is breathable, why nobody's using lime? Because you apply lime, probably then, it doesn't last very long. It's not very economical. And the solution here to solve the issue, cement, we have issues obviously with cement, creates condensation and salinity issues. And what we do, basically the solution here, is we apply the base coat, either on 2 coats underground, 1 coat above ground. And technically, if you have a cellar which is completely in really, really bad conditions, you have high water tables and leaks and everything, if you apply enough material, and let's say if you would waterproof the whole cellar, paying attention to the corners, to reinforce along the corners, where the building tends to move, you can create, even in a high water table scenario, you can create a completely dry cellar, so the whole neighborhood can swim and flood, and it will stay dry. And you need to mitigate the problem when you have these high water table scenarios, there is a flood, maybe for a week or a few days until the water table goes back to normal. And you can completely do that.
And in terms of doing the floor, obviously, unfortunately, a lot of cellars have a concrete floor, a concrete screed. You can apply this over the concrete screed.
If the concrete screed is, let's say, is stable, that is, you don't have actual chunks moving, like you step on it and it's all over, it's completely gone. Yes, you can apply it. Obviously, it's not going to make it breathable, but it's going to reinforce it, and it's going to actually separate the salts, because the salts are in the cement screed, and you can definitely use it on top of the concrete. Yeah.
And it can be used on a hempcrete or a lime.
Yeah, you can.
Why will it not? Is it strong enough to withstand the moisture potentially coming up through the floor and exploding?
We asked the question, and we asked them basically on one of the videos on YouTube. We have it actually kind of how much is too much, how much pressure actually can withstand. And the old master was smiling and says, well, like 1 square centimeter, like kind of 10 by 10, it can withstand 75 kilos of pressure, like kind of the weight of a man. I have a slide in a moment about flooring. Because if you need to actually have a limecrete floor, you need to actually do a flooring. Yes, you can do the limecrete floor, it's great, but it can be improved, and we have improved it.